All right, lesson 5 in module 2 is on just identifying the transformations. So remember, we're dealing with, our purposes are 4 types of transformations. Translation, reflection, rotation, then dilation. Remember, dilation is a little bit different because in dilations, figures get bigger or smaller, okay? We're going to get to that next. But the 3 we're working with right now are, I make random marks here. Translation, reflection, rotation. Okay, and again, these are called isometries or basic rigid, I'm going to squeeze this in here, motions. Sorry, squeezing it in. But what isometries mean or basic rigid motions is the figures do not get bigger or smaller. If it's a triangle to start, it stays a triangle. The side lengths are the same. The angle measures are the same. Distance preserving, angle measure preserving. Okay? So it says use what we know so far to identify these transformations. So again, we're going to be identifying either as a translation, reflection, rotation, but within each of those, we're going to be specific. If it's translated, where is it translated to? If it's reflected, what's it reflected over? If it's rotated, how many degrees is rotated in what direction? Okay, so we kind of we know our 3, and then there's specifics for each one. Okay, so let's take a look at just number 1 here. Okay, so again, identify our pre-image and our image. This is our pre-image. This is our image. How do I know that? Well, I look for the primes, the apostrophes, right? Okay, so we're going from here to here. Now, this absolutely could be a translation, right? So I'm going down 1, 2, 3, 4. I'm not going down. I'm going up 1, 2, 3, 4, 5, 6. But what happens when I go up from C6? 1, 2, 3, 4, 5, 6. I don't get there. Okay, so it's easy because this are both rectangles here. It's easy to think translation. But I can't just move this up 6 because if I move C up 6, I don't hit there. Okay? Which means, if we look carefully at it, that this is going to be a reflection. Notice that A is 3 units away from the x-axis, and A prime is 3 units away. C is 1, 2, 3, 4, 5, 6 units away. C prime is 1, 2, 3, 4, 5, 6 units away. Even though I didn't do that very well. Okay? So we know this is going to be a reflection. But then we want to be specific over, we need a line of reflection, the x-axis. Okay, we're just flipping it over, creating a mirror image over the x-axis. So our algebraic representation, remember we have our original point, and what's happening to these? Well, if it's a struggle, and I know sometimes it is, notice that A right here is at -7, -3. -7, -3. Sorry, no, it's hard to read. A prime right here is at -7, +3. Okay, so both of these stayed -7. So our x is going to stay the same, but then -3 became +3. So we're going to take the opposite of whatever our y value is. Okay, so this is that coordinate notation we are working with. Excuse me. Let's try another example. All right, so again, this can be in translation. I can take h right here. Nope, I'm sorry. Pre-image. I got to get careful. I got to be careful about that. Image. How do I know it's the image? It's got the prime sides, right? So from here to here, I could take h and go 1, 2, 3, 4, 5, 6, 7, 8 to the left. 1, 2, 3, 4 down. But if I took e here and went 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4 down, I'm not at e prime. So it's not a translation. Okay? Not really a rotation. I'm sorry, a reflection. You kind of visualize it. I guess it could actually be 2 reflections, but we're not into that sequencing, what's called sequencing of reflections. We just want 1 transformation now. Okay? So if you think of it, I'm thinking this is going to be a rotation. Okay? Because if I take the point H to the origin and I swing this around, it creates a straight line with H prime. How about E and E prime? Okay? If I create, you squint a little bit, it's creating a straight line with each of these points through the origin. Okay, so get rid of some of these. So again, you can think of it as we're spinning this around. Okay, same thing with E here, connected. We're spinning it around. So another word for spinning is a rotation. Okay, and it's a rotation 180 degrees because it creates a straight line. Okay, and this is going to be clockwise slash counterclockwise. Okay, and the reason it can be either is because it doesn't matter which way you go. Okay, you're going to spin that around, turn that, it's going to be 180 degrees. So our coordinate notation right here. So this H is at the point 4, 2. And this one is at the point -4, -2. Well, guess what? You can even go off your notes that we've done this before. Our x value is just becoming the opposite, and our y value is becoming the opposite. Okay? Okay, let's maybe pick up the pace here a little bit. Oh, I bet we can figure out this next one. This one's going to be a translation. Like, look, I, j, k, I prime, j, k, j prime, k prime. All right? So we're moving from this figure to this figure. You're moving each of the points the same number. Okay, same number of units. They can't be different because then the shape would change. So you can pick whatever ones you want to move. I'm going to say that this is a translation, first of all. And I'm just going to write how many units we're moving. So again, pick whatever point, but match them up. I'm going to go from j to j prime. So from j to j prime, I'm going to go left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 left. And then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And 8 units up. Okay? So for our coordinate notation, and that works for all of them. 9 left, 8 up, 9 left, 8 up. We're going to take whatever our point is. And remember, left and right is our x movement. Since I'm going left, that's -9. 8 up is our positive movement. It attaches to our y because the axis, y-axis is up and down. So I'm going to +8. Okay? All right, just a few more examples here. We'll go through this pretty quick. Okay? This one, because it's a triangle, I hope it's a little bit easier to see that this is going to be a rotation, right? Because we can't reflect it over this line, and we're not just going to translate it because the figure looks different. It's a little more challenging with rectangles. We have to pay attention to vertices. Okay, but again, here's my pre-image, and this is my image, and I know that because of the apostrophes. Okay, so if I look at m and m prime here, remember what we're doing is all of our rotations are going to occur, yes, intervals of 90, right? But it's always going to be the origin. We're always going to be rotating around the origin. That's not always the case, but it's what we're doing. So if you look here, you can see that this is really creating this 90-degree angle. Okay, so I'm going to say that this is a rotation. 90 degrees in what direction? Well, m to m prime is going this way. So that's clockwise. Now, if you think back to your notes, though, they had like 2 things listed, right? Because we really could wrap around this way. And if we wrap around this way, you're going 90, 180, 270. So it really also could be 270 degrees counterclockwise. They're the same. Okay? Their coordinate notation is the same as well. That's why it's really helpful to have that in your notes. So our algebraic representation, our coordinate notation, just take 2 points here. So if I'm just going to take n. This is the point -4, -7. And n prime over here is -7, +4. Okay, so notice we switch the x and y around, y and x, okay? And my y here stayed the same, but my x became its opposite. So we're going to say the opposite of x. So it's going to be y opposite x. Okay? Whatever this y value is, just move it to the x spot. Whatever this x value is, take the opposite and move it to the y spot. Okay, so we have opposite of x. All right, back to rectangles. Again, it can be hard to see. If we look here, I want to say it's a reflection right away because these 2 points are 3 units away on either side. But this Q and this P prime don't match up, okay? This P has to go to P prime. So we're basically moving it to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So be careful. This is a translation. 10 units right. So for our coordinate notation, left and right, that's our x value. So I'm taking whatever x is and I'm adding 10 to it, but my y value is not changing. The figure is not going up or down at all. All right, one more. Okay, again, yay, different type of figure, a little bit easier to see. We could think maybe that it's a rotation, okay? But it's not the same rotation as these W's, right? Like this, oh, that's 90, but W to W prime is not 90, okay? So it's not a rotation. Look at this mirror image created. Oops, sorry. This mirror image, as I try to go fast here, created right over our y-axis here, right? So I'm going to say that this is a reflection over the y-axis. And our coordinate notation means if I take S right here, which is the point 7, -4, and S prime over here, which is the point -7, -4, notice our x value is becoming its opposite, but our y value is staying the same. Okay, so now that we've worked with these transformations, we want to get good at identifying them. And when we identify them, we want to be specific on what is happening to them.